Welcome back to the Career Blueprinters. If you watched part 1, you now know what AI engineering actually is, the skills, the salaries, the reality behind the hype. But here's the thing, getting the job is just the beginning. The real question is, once you're in, how do you stop being a junior who just executes tasks and start becoming the engineer that companies fight to keep? The one who gets called into meetings, who architects systems, who commands the senior salaries we talked about. That's what part 2 is about. We're going beyond the entry roadmap into the territory of true professionals, the specializations, the career stages, the risks that sink most engineers, and the mentors who can shortcut your learning by years. If you're serious about not just entering this field but dominating it, this is your blueprint. Let's get into it. Types of AI engineers and specializations. Once you're in the door, you'll quickly realize AI engineer is an umbrella term. Underneath it are distinct specializations, each with its own daily rhythm. Let's break them down. First, the ML AI engineer, the prediction builder. This person builds models that predict things, churn, fraud, recommendations. They work with tabular data, experiment with algorithms, and care deeply about accuracy versus speed. Think scikit-learn, XGBoost, PyTorch. Their job: turn data into predictions and plug those predictions into real applications. Second, the LLM RAG engineer, the assistant architect. This is the Gen AI builder everyone talks about. They don't train base models, they build on top of them. Chatbots, copilots, document Q&A systems. They work with embeddings, vector databases, and frameworks like LangChain. Their job: design the smart assistants and workflows that sit on top of large language models. Third, the MLOps engineer, the reliability guardian. MLOps, machine learning operations, is the infrastructure side. This person ensures models actually run in production. Docker, Kubernetes, CI/CD, monitoring, logging, versioning. They care less about which model you use and more about, does it stay up, is it fast, and can we safely ship the next version? Fourth, the full-stack AI engineer, the product builder. This is a software engineer who's very good at wiring AI into products. They own the whole thing, front-end, back-end, and the AI in the middle. AI might be 20% of their work, solid engineering is the rest. They want to see users actually using their features. Fifth, the AI research engineer, the lab scientist. This is the academic track. They design new architectures, train massive models, implement research papers. Heavy math, large-scale runs. This is closer to OpenAI, DeepMind, or PhD-level work. Career stages and progression. Once you're in, the path forward isn't random, it follows a clear ladder. Let's map it, from junior to the point where you're shaping strategy, not just writing code. Level 1, Junior AI Engineer, the apprentice. 0 to 2 years. You're working under close guidance, implementing pieces of features, not whole systems. You ship your first end-to-end project with support. Your goal: learn the tools, absorb how real systems work, and prove you can deliver something that actually runs. Level 2, mid-level, the owner. 2 to 5 years. Now you own complete features. You take a real problem, design an AI solution, ship it, and keep it alive in production. You start mentoring juniors. The shift is from helping to owning. Level 3, senior, the leader. 5 to 8 years. You lead complex, critical projects, systems that impact revenue or user experience. The company isn't paying you just to write great code, they are paying you to make sure AI is solving the right problems reliably. You balance technical trade-offs and explain them to stakeholders. Level 4, staff or principal, that is the architect. 8 to 12 plus years. You operate at organization level. You set technical direction across multiple teams, design the AI platform, define standards for MLOps and data quality. You're the go-to for the hardest questions. Your work is invisible but foundational. Level 5, the consultant or lead. At the top, you choose direction. Internal leadership, head of AI, director, less coding, more strategy, roadmaps, hiring. External consulting, working across companies to design AI strategies, audit systems, rescue failing projects. You live on reputation and case studies. The Path Lab strategy. How do you transition between levels? At each stage, ask, what's the problem my manager is losing sleep over? Solve that, and you'll never wait for a promotion. What distinguishes a true AI professional? What actually separates the top AI engineers from the average ones? It's rarely about knowing one more framework. It's about how they think, design, and deliver. Let me break it down. 1. They're outcome first, not model first. The average engineer asks, which cool model should I use? The top engineer asks, what business outcome are we aiming for, and how will we measure it? They'll say no to a fancy neural network if a simple rule-based system solves the problem cheaper and faster. 2. They think critically under ambiguity. When something breaks, the average engineer says, the model doesn't work. The top engineer systematically debugs data issue, label quality, feature engineering, model choice, evaluation metric, or deployment bug. They break messy problems into testable pieces without panicking. 3. They master the practical depth. They don't just know Python and ML libraries. They handle real-world data, cleaning it, feature engineering, robust evaluation. And they design for deployment, monitoring, and scaling from day one, not as an afterthought. 4. They learn continuously, but intelligently. AI changes monthly. Top engineers treat learning as part of the job. But they don't chase every hype cycle. They test new tools against real use cases and adopt only what actually delivers value. 5. They translate complexity for humans. They can explain model behavior to non-technical stakeholders in plain language. Asterisk, we can gain 3% accuracy, but latency doubles and cost triples. Here's the trade-off. Asterisk, they write clear docs so others can maintain their work. 6. They own systems, not just code. The average engineer builds a model and moves on. The top engineer owns the whole system: data, code, deployment, monitoring, drift detection, fallbacks. They design for the real world, not just the notebook. 7. They think about ethics and impact. They actively consider bias, fairness, privacy, and misuse. They ask, should we build this? Not just, can we build this? They push back when AI would do more harm than good. The Path Lab summary. The difference between the two. Average engineers execute tasks. Top engineers deliver outcomes, build trust, and make everyone around them better. Risks and challenges of the role. AI engineering pays incredibly well, but the money comes with real risks that can sink projects, reputations, or entire careers if you're not prepared. Let's start with the technical challenge. According to EBSUDO's 2026 AI Risks Report, model drift is a silent killer. Your model works today, but real-world data shifts overnight and accuracy drops from 95% to 60%. Scalability nightmares hit when that cheap prototype becomes $1 million production bill. And debugging? Unlike normal software, AI fails probabilistically. It worked yesterday becomes the most frustrating phrase in your vocabulary. Then there are ethical and regulatory risks. Bias amplification. Models trained on skewed data make discriminatory decisions in hiring, lending, or policing. Hallucinations where LLMs confidently spit out wrong answers, catastrophic in healthcare or finance. Privacy violations when models memorize sensitive customer data. The EU AI Act and global regulators are watching. One bad deployment can land you in legal crosshairs. And finally, career risks. The hype bubble is real, ByteTrending's 2026 analysis warns that companies are realizing 80% of AI projects fail to deliver ROI. Engineers without production experience get cut first in layoffs. Skill obsolescence hits every 6 months, new frameworks, new models. And burnout from the constant pressure to deliver magic with immature tools is driving talented people out of the field. The Path Lab bonus. As one Reddit engineer put it, the industry is flooded with prompt engineer juniors, but real production experience is scarcer than ever. The top engineers succeed not by avoiding these risks, but by designing for failure from day one. Gaps and future of the role. Here's the uncomfortable truth about AI engineering in 2026. The field is being disrupted by AI itself, even as demand for top talent explodes. Let's start with the talent gap. According to Pluralsight's 2026 tech forecast, entry-level tech jobs have declined by 50% at major firms since the pandemic. Routine tasks once used to train newcomers are now automated. But here's the paradox. The Lightyear Insights 2026 AI Workforce Report shows a massive shortage in production skills, with thousands of unfilled positions in tech hubs like Seattle alone. What's being automated? Low-code platforms and AI agents now handle 60 to 80% of junior tasks, basic RAG pipelines, model selection, simple APIs. Agentic workflows self-orchestrate multi-step processes that used to require human-designed pipelines. AutoML handles feature engineering and hyperparameter tuning. But where's demand exploding? 3 areas. First, MLOps and AI platform engineering. Companies need battle-tested engineers who can build internal platforms so non-AI teams can self-serve models safely. Second, enterprise AI integration. Wiring LLMs into legacy systems with governance and audit trails, regulated industries like finance and healthcare pay premiums for this. Third, AI safety and governance. As the EU AI Act ramps up enforcement through 2028, demand for bias detection, red teaming, and compliance engineering is skyrocketing. The net outlook: entry-level routine work shrinks 30 to 50% by 2028, but production and strategy roles grow 3x as every company becomes AI first. Winners adapt to AI systems engineering, not just pure model building. Mentors and communities to follow. If you want to stay ahead in AI engineering, don't just follow the hype, follow the people who actually ship real systems. Let me point you to the ones worth your time. First, the individual builders. SWYX, former AWS and Netflix engineer, now CEO of SmithOS. He writes the definitive AI engineer roadmap and breaks down LangChain patterns before they hit mainstream tutorials. Chip Huyn, Stanford adjunct, ex-NVIDIA. Her book Designing Machine Learning Systems is the MLOps Bible. She explains production realities without the fluff. Hamel Hussein, ex-GIT Hub, built Copilot evaluation systems. He shares battle-tested frameworks for LLM evaluation and open-source tools you can actually use. Sebastian Raschke, author of Machine Learning with PyTorch. He turns dense research papers into production-ready code you can understand. LMSYS.org is the open-source leader. Their chatbot arena and evaluation frameworks show what works in the real world before commercial vendors catch up. LangChain and LangGraph teams, Harrison Chase and crew. Every new agent pattern emerges here first. Follow their GitHub and Discord. And practitioner communities. The Made with ML Discord has 20,000 engineers sharing debugging sessions and MLOps templates. Less hype, more how did you actually solve this? What makes these worth tracking? They don't just tweet papers. They ship systems at scale, Copilot, Enterprise RAG, observability platforms, and then share what broke and how they fixed it. Path Lab tip: follow people with war stories from production, not just conference talks. So there it is, the blueprint for moving from an AI engineer who does tasks to one who owns outcomes. We covered the specializations, the career stages, the features of true professionals, the risks that can end your career if you ignore them, and the mentors worth following. Now I want to hear from you. We've done deep dives on AI engineering. But what's next? Which job role should we put under the microscope? Drop it in the comments. Data scientist? Product manager? Cybersecurity analyst? Something else entirely? Whatever role you're curious about, or maybe worried about, let me know. That's our next blueprint. And if this video helped you see the path more clearly, share it with someone who's been asking you about leveling up in AI. Give them the map before they take the wrong turn. This is part 2 of our AI engineering deep dive. If you missed part 1, I'll link it below. It covers everything you need to get into the field. Subscribe if you want the truth behind the salary, not just the hype. Until next time, build systems that don't break and careers that last.